While using virtual reality, many users are limited by their available physical play space, as the play spaces conveyed by the virtual experience are often much larger in scale. This makes it difficult to move around naturally, which makes the experience worse. Research has been made into methods of manipulating the user to translate their physical play space more effectively into the virtual world. One of these methods is redirected walking, and along with that, this project tries to incorporate physical objects in the play space to increase the user's immersion. There are several methods within redirected walking. These techniques include algorithms for steering gains, curvature manipulation, and change blindness. Steering gains and curvature manipulation intend to make the user believe they are moving naturally in the virtual environment, but physically they use less space in the real world. Change blindness is a technique aiming to change the virtual environment without the user discovering it. As long as the gist remains the same, the user will most likely fail to notice any change. If the user notices the change blindness, it can break their immersion, which is vital to the VR experience, since it enhances the user's satisfaction of the experience. One way to increase the user's immersion is through their feeling of presence in the virtual environment. Research has shown that presence can be enhanced by using passive haptics in the experience. This can be implemented in VR by tracking a physical object in the virtual world. This physical object will be tied to the virtual world and can be a hindrance while using redirected walking, since the goal often is to decouple the physical and virtual world. With this in mind, we need to implement passive haptics in a way that one physical object was tied to multiple virtual objects. This implementation would then be evaluated based on its ability to increase presence over a conventional controller. We decided to make an escape room game. This would provide opportunities for implementing redirected walking to utilize a larger virtual environment along with passive haptics to include interactive puzzle pieces, which utilizes different virtual objects. The game included 3 rooms, one where the user used a ball maze for interaction, another where they need to keep a flame lit, and a room where they need to align shadows on the ceiling using the object as a flashlight. For the evaluation, there were 2 groups of participants. The control group played the game with a VR controller, while the other group used the physical object. Each participant answered questionnaires and participated in an interview to obtain relevant information about their experience. From the results, we learned that the physical object did not have any significant effect on the player's presence. This can be due to the fact that the lab where the evaluation was conducted had a lot of noise, which had a negative impact on the user's presence. In the end, the project could not confirm any of the hypotheses presented in the evaluation. This meant that the problem formulation could not be supported either. Flaws in the evaluation and the design of the prototype could be fixed by ensuring a soundproof environment and clearer objectives. The principles of the prototype could be implemented in other applications, but the aforementioned problems prevented us from concluding anything scientifically significant.